All right, everybody, what's going on? Got another statistics video for you. This one is measures of central tendency, mean, median, and mode. It's not too bad. I'll go over the mean, median, and mode, and we will also do a trimmed mean and a weighted average. That'll be the last two examples we do. So let's go ahead and get started. So the mode of a data set is the value that occurs most frequently. So that's pretty easy to get there. All you got to do is see which number appears the most. And you can see here the 4, it appears 1, 2, 3, 4, 5 times. There's no other number that appears more than that, and so the mode would be 4. And then for this one, you can see here the 2 appears twice, but also the 5 appears twice. So for this one, the modes are, the modes are 2 and 5. So it's basically the number, the value or values that appear the most. Okay, so in this one we have 2 modes. All right, and that's all it is for mode. It's the number or numbers that appear most often. All right, so how to find the median? The median, and that should be that should not be then, it should just be the median is the central value of an ordered distribution. So to find it, the first thing you want to do is order the data from smallest to largest. All right, so that's the first thing you've got to do. For an odd number of data values in the distribution, the median equals the middle data value. And for an even number of data values in the distribution, the median is the sum of the middle 2 values divided by 2. All right, so the main thing here is make sure you put the numbers in order from smallest to largest. And then it's just the one in the middle. All right, so for this one, let's see, the numbers 18, 18, 19. All right, so these are already in order, okay? And you can see that 19 is the middle number here. So the median is equal to 19. All right, now I'm going to show you a little trick in a minute for the median that's going to come in very handy. We don't really need it for this one, for this problem, but I'll come back and show you how it works on this one. But when you have a bunch of numbers, like 20, 30, or 40 numbers, it'll help you determine which one's the middle number. All right, so this one, well, first thing we need to do is put them in order. So we've got 18, 19, 19, 27, 28, and 35. And so you can see we have an even number of values here. And you see here that the 2 numbers in the middle are these 2. You see that? And so the median is equal to 19 plus 27. You add the 2 numbers together and then divide by 2. And that's going to be 23. All right. All right, so far, nothing difficult. Okay, everything's pretty easy. Now, how do we find the mean? Well, you already know how to find this. You've probably done this all through school, averaging your grades up. You basically add all the values up and divide by however many numbers you have. All right, so first thing we have to do is compute the sum of x. Now, I want to stop for a minute and talk about this symbol here. This notation, that means the sum, means to sum the values up. This is important that you understand what that symbol means, because it's going to come up later on in other formulas other formulas that are more complicated looking than this, and it's going to have this sigma in there, which means to sum those values. All right, understand what it means, so then when somebody gives you a formula, you can look at the formula and you know what to do. All right, so compute the sum of the x values, which that is find the sum of all the data values. Divide the sum total by the number of data values. So you add up all the values, divide by however many there are. And we have a sample statistic, which is x bar. That's the sum of all the x values divided by n. And the population parameter mu, okay, is the sum of all the x values divided by capital N. And little n is the number of data values in the sample. Capital N is the number of data values in the population. And hopefully by now in statistics you know the difference between a sample and a population. So just a quick example. Let's say you're going to school somewhere. So and we wanted to do some research or find some information on, say, the height of students. Okay, so if we wanted to find the height of all the students at a school, well, we could go and ask every single student there how tall they are. Okay, now that might be something difficult to do, get in contact with every single student, but that would be the population. That's everybody there. So what we might do instead is, so like if I'm teaching 5 classes, okay, I could just ask all the students in my classes how tall they are and base the average height on that. That's a sample. I took a sample from just a sample of students from the entire population. All right. All right, so let's look at this. Find the mean of the data. All right, so the mean, so we've got x bar is equal to, that's 58 plus 67 plus 60. I'm not going to write it out like this every time, but I will on this example. Plus 84 plus 93 plus 98 plus 100, and that is divided by 1, 2, 3, 4, 5, 6, 7. Okay, so we just added them up, divided by 7, and that is going to be 560 over 7, which is equal to 80. And that's your average, or your mean. All right, so there it is. That's mean, median, and mode. Okay. Now let's get down to some extra stuff. This is going to be a short video because it's not a lot to it, but let's get down to the other stuff. How to compute a 5% trimmed mean. Okay, so first thing we want to do is order the data from smallest to largest. Okay, so when you're finding the mean, you just add the values up like we did in this example. Add them up, divide by however many there are. But for a trim mean, you have to first order them from smallest to largest. And then we delete the bottom 5% of the data and the top 5% of the data. All right. Now, this procedure, this is going to be the same. You would go about this the same way if it was a 10% trim mean. Okay. But they're just asking us to do a 5% trim mean. All right. Note, if the calculation of 5% of the data values does not produce a whole number, round to the nearest integer. So in other words, if you do 5% of the data values and you get something like, say, 1.3, you would have to round. If you get 1.7, 2.8, you round to the nearest whole number. or the nearest integer. Okay, and then compute the mean of the remaining 90% of the data. All right, so, and of course, if this was a 10% trim mean, you would have to do 10% instead of 5%. Okay, so that would be, you would compute the mean of the remaining 80% of the data. All right, so compute the following for the data below. So we've got these data values here, and we want to find the mean for the entire sample, a 5% trim mean, find the median of the original data, find the median of the 5% trim data set, and then they want to know, does the median change when you trim the data? What do you think? Just think about it right now. Do you think it'll change? And is the trim mean or the original mean closer to the median? All right, so let's answer these questions. So to compute the mean for the entire sample, that's x bar equals the sum of all the x values over n. And so the sum of all the x values, we're going to take all of these numbers and we're going to add them up. And I'm not going to write it all out like I did before, but you just punch all these in your calculator, add them up. So that equals 719 divided by 20. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 2 rows, so there's 20 values. And that equals 36. So there's the mean for the entire sample. All right. Now, let's compute a 5% trimmed mean. All right, so how do we go about doing that? All right, so the first thing, so notice our data values, they're already in order from smallest to largest. Okay, and how many data values do we have? We have 20. So we're going to take 20 times 0.05, and that equals 1. Okay, so we're doing a 5% trim mean, so we're going to take the 5% times the number of data values. If they were asking for a 10% trim mean, we would multiply by 0.1. Okay, all right, but they're asking for a 5% trim mean, so we're taking the 5% times the number of data values, and that equals 1. So what did it say to do? Delete the bottom 5% and the top 5% of the data. So we need to delete 1 from the bottom, 1 from the top. Okay, whatever you get for this number right here, that's how many values you delete from the bottom of the set and from the top of the set. And so now we're just left with these values. And so the 5% trim mean, the 5% trimmed mean is equal to, so what we do here is we add all the values except for this one and this one. So we're adding up the 20, 20, 20, 20, 23, this, all of these to this number. So we're adding from this one to this one. And when we add those up, we get 625 divided by what? Well, it's divided by 18 now because we eliminated this value and this value. And this gives us 34.7 is our trim mean. All right. All right, so now it says find the median of the original data. So find the median of the original data. All right, so before we do that, I want to come up here and let me write something down here, a little something helpful. All right, so this, for an ordered data set of size n, position of middle value equals n plus 1 over 2. All right, this right here, you're going to use for the median. It tells you where the middle value is. Okay, it tells you the position of the middle value. So let's look at this. So let me erase this. All right. So we're looking for the median here. Okay. So how many data values do we have? We have 20, right? We have 20 data values. So that means n is 20. So we have 20 plus 1 over 2 is equal to 10.5. All right. That's the position of the middle data value. That is not the median. This tells you where the median is located. All right. So we start here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's halfway in between this number and this number. Okay, it's between the 10th and 11th value because we got 10.5. Okay, and so we know when we have an even number of values, how do we find the median? Well, these two are in the middle, right? Because look, if we took these values and kept writing them 35, 35, and so on, you know, if we took this row and continued up here instead of had them stacked, the 10.5 is right here between these two. So these are your middle two values. So the median is equal to 30 plus 35. See, adding these two together, divided by 2, and that ends up giving us 32.5. 32.5. All right. And then what they ask us to do is find the median of the 5% trim data set. All right. So look at this. So what they're saying here is the trim mean, find the median of the 5% trimmed data set. So we're going to take this off, but think about it. You're taking the same amount of numbers off from each side. So the two middle numbers are not going to change. So the median is going to be the same. The median is still 30 plus 35 over 2, which is 32.5. It's not going to change. Okay, and it asks us there, does the median change when you trim the data? No, because you're taking the same amount of data values off of each side, so the middle's not going to change. And then it says, is the trim mean or the original mean closer to the median? All right, so the median is 32.5. Here's the original mean. Here's the trim mean, and we can see that the trim mean is closer. So we would write the trimmed mean is closer to the median. All right. So there you go. There's trim mean. You picked up a little tip here on how to find the keyword here, position of the middle value. Okay, it's not, this n plus 1 over 2 is not the median. It's the position of the median. It's just an easier way to find it when you have a large number of data sets. See, like up here, Let's go up here. See the median here? Find the median of the data. Well, I mean, obviously we know that's the position. Right? It's right here is the middle value. But look, we got 1, 2, 3, 4, 5. So 5 plus 1 over 2 is 6 over 2, which equals 3. So there's your median. 1, 2, 3. It's the third number. And same thing here. We got 1, 2, 3, 4, 5, 6. So we got 6 plus 1 over 2 is 7 over 2, which is 3.5. So 1, 2, 3. It's right here in the middle. So we're going to use the two numbers in the middle to calculate the mean. Well, I'm sorry, not this one. This one, 1, 2, 3.5. So we used these two. I was up here on this one, but those are not in order, so we can't do that one. We got to come down here to this one. All right, so there it is on the position. All right, so last example here. Well, it's actually two of them, but it's on weighted average. So the weighted average is the sum of x times w over the sum of w, where x is a data value and w is the weight assigned to that data value. The sum is taken over all data values. All right, so let's look at an example. All right, so we have in your biology class, your final grade is based on several things: a lab score, scores on 2 major tests, and your score on the final exam. There are 100 points available for each score. However, the lab score is worth 25% of your total grade. Each major test is worth 22.5%, and the final exam is worth 30%. Compute the weighted average for the following scores: 92 on the lab, 81 on your first test, 93 on the second test, and 85 on the final. All right. So let's see what we've got here. So your weighted average would be, okay, so what did it say to do? You've got to take the score times the weight and add all those up. All right, so let's see here. We got a 92. Let me just kind of underline each of these so they kind of stand out. This is on the first test, 93 on the second, and 85 on the final. And then let's underline the weights. The lab is 25, each test is 22, and the final is worth 30. All right, so for the lab score, let's see, 92 on the lab, so that's 92 times, and it's worth 25%, 0.25, plus, and then we made an 81 on the first test, and that's worth 22.5%, 0.225, plus, and then a 93 on the second test, so that's 93 plus, 93 times 0.225, plus, and then the final, we made it 85, so that's 85 times, and that's 30%, 0.3. Okay, and that's what this means right here, x times w. Sum all x times w plus x times w plus x times w plus x times w. That's what that means. And then divided by the sum of the weights. And so that's going to be 0.25. See, that's the lab. And then the test is 0.225 plus 0.225 plus 0.225, because we got two of them, plus 0.3. And when you plug all of that into your calculator, you get 87.65 is your final average for the course. All right. Now, what about this one? Find the weighted average of a data set where 10 has a weight of 2, 20 has a weight of 3, and 30 has a weight of 5. And notice the weights, they're not percentages. So this is going to be 10 has a weight of 2, plus 20 has a weight of 3, plus 30 has a weight of 5. And that's going to be divided by, see, this is your x times w plus x times w plus x times w. And then divided by the sum of the weights. See, there's your weights right there. So that's 2 plus 3 plus 5. And this ends up being 23. All right. So, you know, that's weighted averages. Let's see, 20 plus, let me just make sure that's right. Yeah, divided by, yep. Just making sure I calculated that right. Got to double check myself or I'll hear it in the comments. But yeah, that's weighted average. And so, and that brings us to the end of the video. So I hope you learned something. Check out my other videos. Give me a like, share, subscribe, comment. And I'll see you in the next one. Later.